Alright folks, let's dive into the fascinating world of gas laws in just under 3 minutes. These laws are fundamental principles that help us understand how gases behave under different conditions. They are not just theoretical concepts but have practical applications in our daily lives. Whether you're a science whiz or just curious about how the world works, this is for you. First up, Boyle's Law. This law is named after Robert Boyle, a 17th century physicist and chemist who was one of the first to study the properties of gases systematically. Imagine you're holding a balloon. This simple object can help us understand complex scientific principles. If you squeeze it, reducing the volume, what happens? The pressure inside increases. This is a direct demonstration of Boyle's Law. Boyle's Law tells us that pressure and volume are inversely proportional, meaning when one goes up, the other goes down, as long as the temperature stays constant. Pretty cool, huh? This principle is crucial in various fields including medicine, where it helps in understanding how our lungs work. Next, we've got Charles's Law. This law is named after Jacques Charles, a French scientist who made significant contributions to the study of gases in the late 18th century. Picture a hot air balloon. This is a perfect example to understand Charles's law. When you heat the air inside, it expands, making the balloon rise. This is because the volume of the gas increases with temperature. Charles's law states that volume and temperature are directly proportional. So if you increase the temperature, the volume increases too, as long as the pressure remains constant. This law is essential in understanding how hot air balloons work and why they rise when heated. Easy to remember. Now let's move on to another fascinating law. Now let's talk about Gay-Lussac's law. This law is named after Joseph Louis Gay-Lussac, a French chemist and physicist who studied the relationship between temperature and pressure in gases. Think of a can of soda left in a hot car. This everyday scenario can help us understand Gay-Lussac's law. The car heats up, and so does the gas inside the can, increasing the pressure. This can sometimes lead to the can bursting if the pressure becomes too high. Gay-Lussac's law tells us that pressure and temperature are directly proportional when the volume is constant. This principle is vital in various industrial applications where controlling gas pressure is crucial. Heat it up, and the pressure climbs. Simple as that. This law helps us understand why it's dangerous to leave pressurized containers in hot environments. Finally, we have the combined gas law, which brings Boyle's, Charles's, and Gay-Lussac's laws together. This law is a comprehensive way to understand the behavior of gases when multiple variables are changing. This one's a bit trickier, but it basically shows how pressure, volume, and temperature are all related. It's a powerful tool for scientists and engineers working with gases. The formula is P1V1/T1 equals sign P2V2/T2. This equation allows us to predict how a gas will behave when subjected to different conditions. It's like the holy grail of gas laws, combining everything we just talked about. So, to recap, Boyle's Law is about pressure and volume. Boyle's Law is about pressure and volume. Remember, when one goes up, the other goes down. Charles's Law deals with volume and temperature. Increase the temperature and the volume increases too. Gay-Lussac's Law covers pressure and temperature. Heat it up and the pressure climbs. And the combined gas law ties all three together. It's a comprehensive way to understand the behavior of gases under various conditions. There you have it, folks. Gas laws in under 3 minutes. These principles are not just for scientists, they help us understand everyday phenomena. Next time you see a balloon, a hot air balloon, or even a soda can, you'll know the science behind it. These simple objects are governed by the same laws that scientists use to explore the universe. Thanks for watching, and don't forget to subscribe for more quick and easy explanations. Catch you next time. Keep exploring, keep learning.